All right, one last topic with combinations is where we actually going to combine combinations. Um, Here's an example of where you might see something like this, and then I'll show you some examples of just calculations in this regard. So, on a basketball team, there are 12 players. This is pretty common actually for a basketball team, and five starters and seven bench players. So, five players play on the court at a time. Consider your five best players as your starters, typically, or at least the best player at each position, and then your seven players coming off the bench. And during practice, the coach wants to make a team of two starters and three bench players. Okay, so out of these five, he wants two of them, and out of these seven, he wants three of them for a scrimmage. And in how many ways can this be done? Okay, so an applicable problem. And now, uh, to make this calculation, it doesn't matter the order in which those players are chosen, right? So if he wants to choose two starters out of the five, it doesn't matter if he chooses one first and the other. It just needs two, okay? And the three out of the seven, again, it doesn't matter what order. He just needs to get three of them out there. So what we want to do then is calculate two separate combinations and then multiply them together, okay? Because the final result is going to be the product of the starters times the bench player. So if he picks the two starters out in a certain number of ways, then he picks, then for each of those ways, he can pick the bench players in another number of ways, okay? And so then you multiply them out to get the final product. So to get each one of these, you're going to take, let's see, 5, choose 3, 5 choose or no, I'm sorry, 5 choose 2. That's your starters, right? 5 choose 2. Yep. And then you're going to multiply that by 7 choose 3. Again, the order doesn't matter. That's why we're using the combination formula rather than the permutation formula. And so to make each of these calculations, what I would do is just calculate each of these separately and then multiply them, although there are times where it's convenient to actually do this all in one shot. So what I'm going to do here is take the 5, choose 2. We know that that is 5 factorial over, now you're going to have a 2 factorial and the difference between them factorial, which is a 3. So it's going to be 3 factorial, 2 factorial on the bottom. All right, and then with the 7 choose 3, I'll just get that one set up and then we'll calculate these. 7 choose 3 is going to be 7 factorial over, and then we're going to have a 3 factorial and then the difference, which is 4. So it's 4 factorial, 3 factorial. Okay. So now we just have to calculate these two things. The first one, I'm going to do some canceling. So we've got 5 times 4 times 3 factorial on top. And on the bottom, I have a 3 factorial that I'm going to cancel with that. So I'll write it underneath. That's just, I like to group these things together. And then I've got a 2 factorial, which is just 2 times 1. Okay. So you can kind of see how I group together the 3 factorial with all the stuff from 3 on in the 5 factorial. Anyway, I can cancel the 3 factorials. The 2 will reduce with the 4. And so I really have just 5 times 2, which is 10. Okay, so I have 10 different ways of choosing 2 players out of the 5 starters. 10 ways to do that. With 7 choose 3, I calculate that out. Now I always cancel the bigger factorial usually, first. So this is 7 times 6 times 5 times 4 factorial. I'm going to get rid of the 4 factorial on the bottom with it. And then there's a 3 factorial, which is 3 times 2 times 1. I cancel the 4's out, and what's nice is the 3 and the 2 cancel out together with the 6, right? 3 times 2 is 6, so I can cancel all that out. And I'm left with just 7 times 5, which is 35. Okay. So the end result, the number of ways that these players can be chosen, or the number of teams essentially that he can make, is going to be the product of these two numbers, which is 10 times 35, or 350 ways. put a T there. There we go. So there are 350 ways to create that team for the scrimmage. And now just an additional problem, if you were to, if you wanted to make a second team with the same combination of players, which would be 2 starters and 3 bench players, then he'd be limited. Once he made the first team, he'd be limited in how many other players were left, right? So essentially, if you wanted to make a second team, say you wanted to, this scrimmage, you wanted to have the 2 teams play each other, for instance, then on the second team, he's not going to have 5 starters to choose from. He's already going to have chosen 2 of them, so he's going to have 3, a pool of 3 to choose 2 from. So it would be 3 choose 2, and then with the bench players, he would have already pulled out 3 of them, so he would have 4 bench players and 3 to choose from out of there. So it'd be 4 choose 3. Yeah, 4 choose 3, and that would get him his total number of players is 5 players for the second team. Of course, there'd be 1 starter and 1 bench player left off of both teams, and so what we can do is multiply these together. Let's see. So it'd be 3 choose 2 is 3 factorial over 1 factorial 2 factorial. Right? Together have the difference and the r on the bottom. And so that's going to be just 3. Right? Because it's 3 times 2 factorial. The 2 factorials will cancel and just get 3 left over. 4 choose 3 is 4 factorial over 1 factorial 3 factorial, and again this is just 4 times 3 factorial. 3 factorials will cancel and you just get 4. Okay, and so the number of ways, once this coach has chosen the first team, the number of ways in which he can choose the second team is limited down to 12. Okay, it's the 3 times the 4. Right. Okay, so that gives you an idea of how to calculate these when you're combining multiple formulas in the same problem. Now, when we start getting into probabilities, we'll be seeing some other combinations of formulas. You'll be doing some dividing of these. You'll be doing some multiplying, some subtracting. And so let me give you a couple just real quick examples of some of those combinations to work with. Get rid of this example here and try to fit this all in the same video, I guess. So so if I had some larger combinations, maybe some fractions to work with, we maybe do something like 5 choose 3 times 4 choose 2 all over 12 choose 5 or something like this. Wondering if that's not quite going to be enough, but we'll see. We'll make that. Hopefully that'll work out. Might be too big on the bottom, but anyway, so something like this we can calculate, and sometimes you'll have to do like a product over something else, so like a big fraction. And so again, there are different ways you could approach this. One is that you could calculate each of these individually, or you could actually think of this as the first 2 times 1 over the bottom and just flip the fraction for the second one and then just cancel a bunch of stuff. It kind of works out nicely that way. So maybe I'll try it that way. If I were to look at this as 5 choose 3, that's 5 factorial over 2 factorial 3 factorial. Again, you always want the n on top, the r on the bottom, and then the difference between the 2 on the bottom as well for these combinations. So that's first fraction. Then you have 4 choose 2, which is 4 factorial over 2 factorial 2 factorial. And then on the bottom, you're going to have 12 factorial over 7 factorial 5 factorial. Okay. And so with this combination, then what I might do is write the first two fractions normally and then flip the second fraction, do a copy dot flip or a multiply by the reciprocal. Remember, whenever you divide by a fraction, it's the same as multiplying by its reciprocal. So I might write this out as 5 factorial over 2 factorial 3 factorial times 4 factorial over 2 factorial 2 factorial times, now this last fraction I'm going to flip, so it's 7 factorial 5 factorial over 12 factorial. Okay, and so now I just try to cancel stuff off, and this should work out kind of nicely. Yeah, so I've got try to pair up some things that'll really drop out well. So this 5, maybe I'll take the 5 and drop out the 3 factorial. So it's really 5 times 4 over 2, right? Because I'm canceling out the 3 factorial on the end of this, and the 2 factorial is just 2. With the 4, maybe I'll cancel out a 2 factorial again, so I get a 4 times 3, and then the other 2 factorial is just a 2. And then this one, maybe I'll cancel the 7 factorial off of the bottom. So I'm going to have 5 factorial, 5 times 4 times 3 times 2 times 1 on top. The 7 factorial will cancel. I get 12 times 11 times 10. Oops. 10 times 9 times 8. Alright, and so now I just have to cancel some more stuff. So it's just a little bit easier if I'm not using a calculator for this, because this way I can get a bunch of stuff to cancel off before I go through and do the calculation. So I might take 2 of these 2's and cancel them off with a 4. That's kind of nice. And then I just try to group things together in ways that cancel nicely. So here's a 4 and a 3 with a 12. I've got a 10 here. This 10 with the 5 and the 2, those will cancel. That's kind of nice. And then, so my whole numerator over here is gone. These denominators are gone. I can't really get rid of this 5. This 4 can cancel with the 8 over there. So 4 with the 8 makes the 8 a 2. And then this 3 with the 9 makes the 9 a 3. I'll put that 2 underneath just to be consistent. And so it looks like I have a 5 on top. And the denominator is 11 times 3 times 2. Well, that's 6 times 11 is 66. So I get 5 out of 66. Okay. Now this could be an example of where we might calculate a probability based upon certain conditions. Okay, so maybe the probability of this event occurring is 5 out of 66. Okay, so anyway, that's where you might see an example of something like this. But again, we're just trying to combine these things and calculate them in a way that simplifies the arithmetic here. You could, of course, punch them in a calculator, but I think that is even a bit confusing because you're going to have to group a bunch of stuff in parentheses in order to pull that off. But it could be done too. So your calculator could work here, or you can just kind of combine them, cancel stuff off nicely like I did, and try to get to an answer.